Alright, let's get started. Alright, so hello everyone, I am Steven, I am the Community Director here at Hack the Hill, and I'll be one of your MCs for this event. Alongside me, I have Pav, who will be MCing the event with me as well.
Bonjour à tous, je suis Pav, je suis le directeur de l'équipe de la logistique de Hack the Hill. Et comme Steven vient de juste de le mentionner, je serai votre animateur pour cet événement et Steven serait mon co-animateur. So for those who are unfamiliar with who we are, so Hack the Hill is an internationally hosted hackathon taking place right here on campus. So this year is taking place on campus here. It's going to take place in CRX, if you don't know. Our organization is made up of various student associations and organizations such as ESS, IEEE, CSSA, and CISA, and Women in Engineering. So in the lead up to our main hackathon, various community events such as this one and the previous ones that happened along the past previous months, we call these the Hacker Series. So these just where will be taking place, and they're essentially introductions or little workshops leading up to the main event, which is a hackathon. So we hope that you will be able to find the time to attend all of these, such as this one. Thank you all for coming.
Pour ceux qui ne savent pas qui nous sommes, Hack the Hill est un hackathon international qui se déroule sur campus. Notre organisation est composée de diverses associations et organisations étudiantes. Alors on a ARG, IEEE, AEI, ARGL et les femmes en génie. Avant le hackathon, divers événements communautaires appelés The Hacker Series auront lieu. Nous espérons que tel que celui-ci, nous espérons que vous pourrez trouver le temps de participer à tous ces événements. So before we start, we would like to acknowledge that the land on which we gather is the unceded territory of the Algonquin Anishinaabe people. The Algonquin peoples have lived on this land since time immemorial, and we are grateful to have the opportunity to be present on this territory.
Avant de commencer, nous tenons à reconnaître que nous rassemblons ce soir sur le territoire non cédé de la nation Anishinaabe et Algonquin. Les peuples de la nation Anishinaabe et Algonquin vivent sur ce territoire depuis des millénaires. Leur culture et leur présence l'ont enrichi et l'enrichissent toujours. Nous rendons hommage au peuple et au territoire de la nation Anishinaabe et Algonquin, et nous rendons hommage à toutes les Premières Nations, à tous les Inuits, à tous les Métis, de même qu'aux précieuses contributions passées et présentes à cette terre. So here's how things are going to go down tonight. First, we're going to have Max from the uOttawa Game Dev Club give an introduction and walkthrough to Unity, just like he already initiated. Then, at approximately 8:30 p.m., we're going to take a break for dinner. So we have pizza, we have snacks, and we have drinks available for you all. And then we'll then get back together and conclude with debugging and showing off additional Unity features.
Donc voici comment l'itinéraire va se dérouler pour ce soir. Tout d'abord, nous accueillons Max du groupe de développement de jeux pour une introduction à Unity. Ensuite, vers 20h30, nous ferons une pause pour le souper. Nous avons de la pizza, des collations et des boissons disponibles pour vous tous. Par la suite, nous nous rejoindrons pour conclure avec du debugging et une présentation des autres fonctions de Unity. So without further ado, please welcome our guest speaker, Max, again.
All right. Yeah, as you can see, my project has loaded. Could we get a quick show of hands? How many of you guys are still waiting on your this screen to open? Your project is still loading. A few people? Quite a few people? All right, yeah. Well, for the meantime, I'll give a bit of an introduction to me and our club. For those of you who are unfamiliar with me, which is all of you, my name is Max. I'm a third year in linguistics and computer science, and I'm the president of our very own uOttawa Game Development Club. Woo! Woo! And yeah, our club is relatively new. We founded it last October with just a couple people. Because uOttawa used to have a game dev club, and then it shut down at the start of the pandemic for a few years, but we revived it. We brought it back from the ashes, and we're still getting on our feet, but Hack the Hill has graciously allowed us to co-host some events with them, and hopefully, you know, we can get you guys, some of you guys interested in game dev as well. So, yeah. Yeah, sure.
We also have our mentor as well, Antonin. Antonin, if you guys don't mind waving in the back. Oh, he doesn't hear me. Antonin, hello. Yeah, we have a mentor as well. And so if any of you need help with Unity or anything, he'll be the guy to help you guys. So maybe you guys can flag him down if you need him.
Yeah, he's cool. He knows what's up. Well, let's see. You know what? While we're waiting, I'll give you guys a real quick tour of the Unity editor here. Actually, can we get another show of hands? Who's still waiting on their project to open? Still quite a few people. Yeah, Unity can be pretty slow. That's one of the disadvantages of being such a robust software with so many features. Is sometimes it's a bit of a wait, but I say it's worth it. But yeah, so. Alright, that pause also made me realize that I forgot to introduce why the heck I'm even giving this workshop. And that's because, well, originally we were going to have someone with, who was professionally working with Unity give the talk, but there were some that ended up falling through, and the Game Dev Club ended up having to take over the actual presentation. So this is my very first time giving a workshop. So I will be trying my best. I hope you guys can work with me here. But I think I'm more than qualified. I've been using Unity for about 5 or 6 years now. I've made a whole ton of games, and I know it like the back of my hand. And I'm gonna try to pass down some of that knowledge to you guys. All right. Well, I suppose. Could we get that show of hands again? Who's still waiting on the project to open? Alright, 1, 2, 3, 4. You know, let's give it like a couple more minutes because I want to make sure I want to make sure nobody falls behind because yeah, we're gonna be coding a whole game together. It's gonna be awesome. So yeah, right now I'll just go through the ins and outs of the editor here. So as you can see, a lot of windows, a lot of boxes. A lot of stuff going on, pretty cool. This big window right in the middle, this is called the scene view, and in here, this basically shows all of the objects that are going to exist in your game. This is the stage that the great play that is your game will take place on. As you can see, right now the only thing that exists in here is our camera. You can see it's got the little camera icon right there, and this outline just represents what the camera will capture. But if we were, for example, to create an object, and the way you create an object in Unity is by going to the hierarchy here. This is, it shows in a list format all of the objects that exist in your scene. We can right-click in there and create something like a 2D object sprites. And don't worry about following this so far. We're going to come back and start from the beginning once everybody's loaded in. But yeah, we can create ourselves a square, and boom, look at it. There it is in the scene view, and you know what we can do actually? We can preview what it's going to look like in the actual game with this big old play button up here. In fact, there's also this game window here. But what will happen when you click play is right now, well, it'll load some assemblies, and then what'll happen is nothing because we didn't add any code or anything yet. But that's our camera and that's our square. Isn't that something? Thank you, you're too kind. No license? Oh, shoot. I guess, I thought you couldn't start Unity Hub without logging in with a license. I think, well, you can, if you go into your Unity Hub here and then in the top left corner, you should be able to log in there.
I'm sorry about this. This is a bizarre error. You should be able to log in there, and then probably under manage licenses, you can, well, gee, you can probably get a personal license for free from Unity. I haven't had to do it for years, but is anybody else having this issue? They're not able to create a project. They don't have a license. No? Oh shoot. Well, is is there going to be a recorded Twitch VOD for this? Yes. Well, I regret to say that we may have to continue while you figure that out, but feel free to check back in the VOD for stuff you may have missed. Yeah, that is unfortunate. Well, anyways, can we get that? Wait, what's that? Anyway, can we get that show of hands one last time? Who's still loading in? I can start without you, but there's like 5 other people who also haven't loaded in. Oh my god! And it's got like the bar is going and everything. It is loading in. It's just taking a long time. Man, this is unfortunate. Well, I can continue with our little intro demo here, because these are things I would have to have explained anyways. So it's nice that we can get them out of the way first, and then come back to them later. So we have our square here. Let's take a look at our square, why don't we, while we're all waiting. This square, you can see once we've selected it in our hierarchy here, we can click it, and then let's draw our gaze to the right of the screen, the inspector. This, as you can see, this is our square. This is all of the information that makes up our square in Unity. Basically, the way objects, like game objects, which is to say objects that show up in your scene, the way they work in Unity is every game object is nothing but a bundle of components. So, as you can see, if we were to right-click in the hierarchy and create an empty object, all it has right now is a transform. And every object in the Unity scene has a transform component attached automatically, which just defines its position, rotation, and scale in the scene. So if we were to go to our square and say, look at our position, we can grab that X value and move it left and right, and you can see it moving there in the scene. Pretty cool. Pretty sick. Same with all the rotations, all the scalings and everything. Those all show up directly in the scene. All right. Well, for the few of you who I'm very sorry the project has not loaded yet, or who do not have Unity, would you guys be able to perhaps partner with the person next to you, observe their work until maybe your scene has opened, because we do got to get this show on the road. It's already 7:22. Yeah. All right, last time. Show of hands. Who's still waiting? What are you? Are you still waiting? Damn. Okay. Well, looks like we're mostly good. So I will get started. There'll be plenty to look back at the Twitch bot if you like, and also I can once we take a break for pizza, I'll put up my GitHub link, which has all the source code on it. You can check that out and update that later if you like. So I'm going to delete everything except for the main camera here. So it's just as if we started a new project, and now we are going to get ready. We're going to get into our actual game. So, all right. I'm gonna try to go slow. If I'm going too fast, someone please let me know. Yeah, first time doing something like this. So, we are going to start by creating our player. So remember this hierarchy window on the left? We're going to right-click in there, and we have all these options. We can create a 2D object, and then under sprites, and then our old friend the square. We can click that, and boom, it materializes into our scene. Except we don't want it to be just a square. We want it to be our player object. This will eventually become our player. So what we're going to do is click on that square, go over to our inspector, and just change the name to player, just like that. Boom. And now it's our player. Look at that. Although, in order to make this our player, we're going to have to give it some controls, and we are also going to have to give it a sprite. So, we might as well start with the sprite, give them some personality. If you guys recall the email that was sent out to you guys last night, there was attached in that email, there was a link to a Dropbox folder, and that folder contains all of the sprite assets that you'll need for this workshop. So if you haven't downloaded that, go download that real quick, and then we can get some sprites into our project. Down here in the folder view, this basically shows all the files of the project. I always like to right-click and create a separate folder for my sprites, but you can really just drag them into the base folder if you like. There's nothing special about that. And me, I've already got all the sprites open here. And for now, let's just bring in all of these. And you can basically just drag them right in, and there we go. And let's also go into our backdrop parts here, and oh, that's an sprite file and a text file. Don't want those. Just gonna bring all of these into our folder, into our assets folder, and let us. Well, before we go into how to set up the sprites and everything, brief explanation of who this little character is. This little monkey astronaut cowboy-esque character. This is Mac, and he is the mascot of the uOttawa game dev. And he's very cute. He's very cool. He's a very cool little guy. Our vice president made all these assets within just a few days. She's very cool. She's over there. If you could give her a round of applause, that would be awesome. Yeah, she's a really great artist, and these sprites are awesome, so I hope we can have some fun with them. And case in point, let us take a look at these sprites down here. Mac run sprite sheet is what the file is called. It's like four Macs running, doing a little run animation right there, it would seem. And yeah, let's get started looking at the import settings for sprites. So whenever you import a texture or a sprite or anything into Unity, you're going to want to look at the inspector here and make sure all of the import settings add up. So this game that we're making, all the assets are pixelated, which means we have to change some stuff here. The only stuff we're going to have to change is the pixels per unit value. Basically that it sets the amount of pixels in the image that are equivalent to 1 unit of Unity space. And since each of these sprites is 64 by 64 pixels, we want to set that to 64 so that Mac will be 1 Unity unit tall in game. Then what we're going to want to do is move down to the advanced settings down here. So because our sprites here are sprites, pixelated sprites and not textures, we're going to want to change the filter mode. If we leave it as bilinear, he's going to get all smudged, because that's basically for really huge complex textures that need like smudging and smoothing, and it basically automatically smooths them. But we want point, no filter, so that each of those pixels shows up nice and sharp. And then we also want to change the format down here under default to RGBA 32-bit, and that will be going too slow. I'll try to speed up a little bit. And that will make sure that all of the colors are perfectly. So let's apply that, and let's get right to it. So we have 4 sprites here. We actually repeat the yeah. And you know what? Why don't we go over that one more time? So yeah, let's go to one of our other sprites. We'll need to do this again here, but what about Mac Jump? we'll need to go up to the pixels per unit, this little measure right here, and change that to 64, and then move down to our advanced filter mode, change that from bilinear to point, and change format from automatic to RGBA 32-bit. Ooh. And now we could just change each of those settings over and over again for each of these sprites, or Unity provides a very cool little thing we can do. Well, first of all, we have to hit the apply button to apply these settings to our sprite. And then we can go all the way up here to the corner. You see these two little slider buttons? You're going to want to click that, and it's going to be this empty window, select preset. Well, what do you mean select preset? There's nothing here. Well, we're actually going to create a preset. Whoa! So we want to click Save Current To, and then this is basically going to save all those settings that we just changed so that we can just kind of click one thing instead of having to click and change like 3 things. We can just change that to, let's say, pixel single sprites. And that basically saves all of our import settings. And now if we want to go to a different sprite, let's say Mac Head, we can go right back up to those little bars icon, click it, and then click, oh, here it is, pixel single sprite. We can double click that, hit apply, and you can see that all of these settings have automatically been changed. So yeah, we only need to do that once. Well, actually, we do need to do it twice, and that's only because some of these sprites are not single sprites, but actually sprite sheets. And the way that we split these up is also pretty simple. We're just going to want to go up to sprite mode here. You can see it's single right now. We're going to want to click that, change it to multiple, and then you're going to want to hit apply again, and then open up the sprite editor. And what that will let us do is split this up. We're going to be able to tell Unity where we want the splits to be between these sprites, and it will break them up into 4 different sprites for us. So now that the sprite editor has opened, we can go ahead and click this little slice button up here, because that's what we want to do, is we want to slice our big sprite sheet up into 4 little sprites. And we get this little menu with these options. And under type, we want to change that to grid by cell count, because we can see pretty clearly here. If we look at columns and rows, this is 1 row and 4 columns, it should seem. So we just change the C value up here in the corner to 4. Leave the rows as 1, and then we're going to slice it. And nothing seems to have happened here. Just make sure to click that slice button and click it a few times for extra measure. Slow down. All right, maybe. I'm sorry. How many of you guys are able to follow? Like, how many of you guys are up to this point right now? Not a lot. Okay. Yeah. Yeah. Yeah, why don't we I'll go for a recap. We can leave this, hit the apply button, close the window, and go back to one of our other sprites. Just to recap. How about this one? We can look at our settings.
Yeah. Sorry, do you mind just toning down on the talking, please? It's very, very loud, and then we can't hear back in the back. Thank you.
Oh.
Start from the square. Start from like putting the start from the beginning. I'd say.
All right.
Just start from like putting the square.
My deepest apologies, ladies and gentlemen. I've been going too fast. So I will go back to the square. For those of you who were able to follow, first of all, congratulations. Second of all, sorry, gonna have to wait a bit before we continue. But yeah, I will be checking better to make sure that we're all following, because yeah, realized now I was going pretty fast. So let's get rid of this this thing here that we've created. So Remember the square? This is going to be our third meeting with the square. In our hierarchy here, this window off to the left, we are going to right click, and we have all these options. Down here are all the things we can create. We want to create a 2D object, so hover under 2D object there, hover under sprites, and then click square. And that should give us our square again, our old friend. Now, how's it going? Are we, have we got our square? Has everyone got our square? Maybe, just, yeah, we could like, have our thumbs at the ready, because, I'll be checking it at each step if we're all following. Got our square? I'm not seeing a lot of squares in the back. Oh man. Can we actually get a show of hands? How many people are trying to follow me right now through Unity? Okay, so not all that many people actually. Okay, well I guess that's... Wait, actually, can you guys in the back hear me? Yeah? Oh, okay. Well, alright, so... We got a square. Now I'll just show the process of bringing the sprites in again. If you downloaded them from the Dropbox, which I hope you have, from the email, all in a folder or a zip file, you can literally just open your zip file and drag them in. That's going to go back. Yeah, you can just grab them one by one or all at once and just drag them right into this bottom folder view right here, and that will put them into your project. So, have we got our sprites? Thumbs? All right.
You know, there's still like a third of the people here that don't have their Unity installed, so I don't want you to like redo it a third time.
No, yeah, I mean, if they don't have it installed, then
Okay,
like,
it's fine.
it'll take like
Yeah.
a long time to install it and get everything open.
Yeah,
Yeah, if you weren't able to install it, yeah, I suppose.
it's fine. I'll help after. Yeah.
All right. Yeah. Verbally yes.
Yeah.
All right. Unready your thumbs. Yeah. Next time I'll be asking for a verbal yes. So ready your vocal cords. All right. So, do we have our sprites? Yes. All right. Okay, that's what I like to hear. So let's just go through the process again. Right now, we're just going to want to look at. Why don't we just look at our Mac run sprite sheet right here. You can pick that out of your files. Make sure you got the right one. It's the one with 4 of the behatted monkey-esque fellow running. You can go ahead and look at your inspector. Make sure to select it in the folder view, the project view. Look at your inspector. Make sure to change that pixels per unit from the default 100 to 64. Make sure to then go down to your advanced settings, your filter mode, and select that and change it from the default bilinear to point, in bracket, no filter, close bracket. And then last but not least, go down to default format and change it from the default automatic to RGBA 32 bits. All right, how many people have been following this far? Get some yeses. Yes. How about some no's? Nobody know? We're all yes.
Well, to shut up and really talk loud, because I think that people can't hear you.
All right. I would ask politely once more that we keep the talking down so that the people in the back can hear. I will also be raising my voice more than I was. Have you guys in the back been able to like consistently follow my voice? Probably not, right? Yeah? No? Okay, well, just to make sure. So yeah, we've all got our sprites imported and set up. And recall, if you haven't already, remember the 2 bars button, the tiny little 2 bars button in the corner. We're going to want to save these settings. as just click that button, open it up, hit save current to, name it whatever you like. I named it pixel single sprite, and you can save it. I already saved it, so I won't be saving it again. And then you can go to any of your other sprites and hit that same little tiny little 2 bars button to use those settings and apply them again. And it's all very simple from there. And then with our multiple sprites, why don't we can take this one as another example. Mac dead sprite sheet. This will be his death animation once we're able to put it, if and when we were able to put it into the game. We can go over here into the bars. Apply. Everybody following so far? Can we get a yes? Yeah. Okay. And yeah, we can get set the pixel single settings. Change the sprite mode to multiple. From single to multiple, since it is in fact multiple sprites. Hit the apply button. And hit the sprite editor. Sprite editor opens. Hit slice. Make sure to change it from automatic to grid by cell count up here in the little slice menu, the little slice button. Change it to the number of columns that there are, which it has 4 from when we put 4 earlier, but this is not 4, it is 2. So we're going to set it to 2 and hit slice. And that should be good. Now we have them segmented cleanly into 2 nice sprites. We can hit apply, and now we can do the same thing even that we did earlier with saving our sprite settings, because the only thing that we've changed is we've changed sprite mode from single to multiple, but we can also save that to pixel multiple. It's pretty cool. All right, who is caught up? Get some yeses. Some yeses. Almost, sure. Take some time. The sprite editor, there's this button right here. If you scroll all the way up to the top of the inspector, when you click on the sprite editor button right there. Yeah. Yeah. Yeah, we'll pause for a second, take questions. What is your question? After you open the sprite editor, good sir, you can go and hit this slice button up here in the corner. And that will take you to the slice menu, because we're going to be slicing this sprite sheet into different sprites, right? And this is 2 sprites, so we're going to want to change type to grid by cell count, which will let us tell it how many rows and columns our sprite sheet is. We want to change it here to however many sprites we have, which is 2 columns and 1 row, and then we're just going to hit the slice button here, and that will give us 2 nice separate sprites. And then you can click out of that menu and then hit apply, and then what if the slice is grayed out? Well, that means you probably forgot to you can close it and go back to your sprite mode and make sure that's multiple. And you're only going to want to do this for the sprite sheets, which is to say the ones that have more than 1 sprites. The single sprites, like Mac Jump Sprite here, are single, so you don't need to change that. But the multiple ones, you're going to want to change that to multiple and go into your sprite editor, and it should be, you should have your slice button there and ready to go. Anybody got any other questions? No? We're all caught up? Question in the back? It does not matter. Yeah, you can do it before or after. Because yeah, the preset, it does save the slicing, but it mainly just saves all of these settings right here. So anything else you're clear on. Just after you just make sure that all of these settings are what you want to save before you hit the save button. All right. Anybody else? Yes. Yes. Because it can get really messy having a whole bunch of individual files. It's more of an organization thing. It's like you'll see in a lot of like in like more professional games too, you'll have like hundreds and hundreds of sprites on one sheet. It's yeah, but it's a very handy thing to know, basically. Although yeah. It's putting the sprite stuff. All right, I'll go through the sprite stuff one more time. You know, maybe this workshop should be a series. You know, like a couple different workshops, and we can finish this one game because yeah, we're a little bit over time right now. My apologies. But yeah. So just to reiterate, you can click one of your sprites. Change the pixels per unit to 64. Change the filter mode to point. Change the format to RGBA 32-bit, and hit apply. And in order to slice, we can go to one of our sprite sheets, of which there are. Good. Yeah. They weren't?
We don't have lasers.
Yeah. You guys do not need those. I guess that was a yes. I guess it wasn't. Don't worry about any of the sprites that you guys may not have that I do in this folder. The ones that we need for today, you guys already have. So yeah, don't worry. But yeah, that was more to just use one as an example. No worries. Why don't we look at the tumbleweed next? We can do all the stuff that we have, you know, pretty good handle on by now. Point, no filter, format to RGBA 32-bit. Hit apply on that. Open our sprite editor with the sprite editor button. And then, well, see, now I have slice grayed out. And that's because I didn't change sprite mode from single to multiple. There's multiple tumbleweed sprites here, and we can change that. Hit apply, and hit sprite editor. And now our slice is not grayed out. Look at that. So you can click that. Make sure to change type from automatic to grid by cell count. All the others are like perfectly fine. Like if you know how big your sprites are, you could also do grid by cell size. But count is simplest for us here. And we want to change that to 4 because we have 4 of our sprites here. We can hit slice to slice those into their individual sprites. Are we good on the slicing? Yes. Yes. Yeah. We're good. We have pretty low. Is everyone good with the slicing? We have conquered slicing, ladies and gentlemen. Let's go. Now, okay, this is going to be an awesome payoff after going through all that, I tell you. So remember our square. Let's go back to our square. You can click on it in the hierarchy here to highlight it and open it in Inspector here. You can see that I've minimized it. Yours is probably still open. It has a sprite renderer component, and that is why that there is a square instead of nothing. Is this sprite renderer component is in fact rendering a sprite. So right now it's rendering the default Unity square sprite. You can see under its sprite parameter here, it has this this square. But we don't want it to be showing a square. We want it to be showing one of our awesome sprites here. So what we can do is look back at that one we chopped up earlier, when we sliced up our Mac run sprite, and hit that little arrow to open it up, and there are individual sprites. Each one is its own thing. And since I've deselected the square, it has disappeared from the inspector, but we can just select that again in the hierarchy. And you're going to want to just grab one of these and drag it into the sprite parameter, and there he is. Isn't that amazing? Has everybody been able to change their square into a fully functional monkey? Yes? Maybe thumbs were better. It seems to be. No? Raise your hand if you're having trouble. I can go through it again. Yes. Yes. All right. Well, I suppose we can continue. Yeah, so I am ashamed to say that I have vastly misjudged the amount of time that the first couple features would take. We will unfortunately not be completing the full game in this workshop today, but I want to show you guys a couple features that will definitely help you guys out if you plan to continue with Unity in the future. Just, familiarize ourselves with a couple things. So why don't we make our player character controllable? Isn't that pretty cool? Well, first of all, why don't we move him down to the middle of the screen? Because this game here that we're gonna make, wow, did I forget to mention? It's a little one of those side scroller infinite runner type games. I don't know if you ever played Jetpack Joyride on your iPod in 2013, like that. And the way that we can move this square, which is, I forgot to rename it to player. If you want to rename it, you can just go into the inspector here and click the name, change that to player. We can actually hit, what else but the W key to activate these arrows to move them. I mean, you can also just change these position values directly here, but I like the arrows, they're fun. So again, select player and hit W to get those, not the Windows button, W to get these arrows shown up, and then you can drag them around as you please, or you can grab this little square here to just move them all over the place. So let's plonk them down right there in the middle. Now, before we do anything regarding the controls, we should give Mac here a floor to stand on, I'm thinking. So, yeah, this hierarchy window here on the left. If you recall, we can right-click on there to create a 2D object. Why don't we make another square? Awesome. A lot of squares today. And we can rename this to floor because this will be our floor. So we've got our floor. Let's get some yeses. Have we got a floor created? Have we got our second square? Yeah! And we can move it. Recall the W key to activate the movement controls. Move it and place it right under our player character here. And we can, in fact, also look at the scale controls here to, whoa, we can stretch it all the way across the screen. So it's a true floor now. Don't have to worry about falling off the edges. Yeah, so again, that's the scale here that you want to change, the X scale, the X axis. And now there's a couple more things we're going to want to do before we add these controls. So Unity has something that's really cool about Unity. It has a built-in physics system. So you could always code your own, but it gets pretty tiresome. So we can just make use of Unity's built-in physics system. It's very simple. The only things that we have to do to turn these objects from sprites into full-on physics objects is we need to give them a new component. So let's highlight our player here on the left in the hierarchy, and look over here on the right in the inspector, and there is this mysterious add component button. If you look at that, so we can click that to add this new component that we need, and the component that we need is, you can type it here in the search bar, a rigid body. And since we're working in 2D and not 3D, we want the 2D version. So you can see there's rigid body, and then there's rigid body 2D. We want the 2D one. You can click that to attach it. Have we all got our rigid body attached? Yeah. Just to reiterate, well, we can do it again. We actually are going to have to do it again for our floor, since we also want that to be a physics object. Click your floor on the left here in the hierarchy, go over to the right, and hit your add component. And it will have saved your search from earlier. Isn't that cool? It's got our rigid body 2D right there. And we can just double click that to add it on, and boom. Now both of our player and our floor are physics objects. But there's a couple more steps we need to take. We want them to collide with one another. And what do you need in order to collide? a hitbox, some kind of bounding area that defines how much space each of these is going to take up. And thankfully, it's also very simple to add one of those in Unity. Just go to your Add Component menu again, and click on the hierarchy on the right here in the inspector, go down to Add Component, and thanks, but we don't need a rigid body this time. What we need is a box collider. And again, there are the 3D and 2D variants. We want the 2D one. So we're going to double click back to add it. And again, we're going to do the same for our player. So we're going to click player in the hierarchy, go over, add component, box collider 2D. Whoa. All right, we got our colliders on? Got our colliders on? All right. We are going to have to change one setting here on the floor because by default, all the physics objects are going to have gravity. Actually, this is a great exercise. Why don't we see what happens if we hit the play button? Because now that they're all rigged up for physics, something's got to happen, right? Why don't we just give it a play, let it load, and oh! He's gone. Just like that. Well, that's nice. That's confirmation our physics are working as intended. They are both falling. They're both being affected by gravity, but we don't want the floor to be affected by gravity, do we? We want the floor to stay. We want Mac to be, jumping up and down, jumping into the air, being pulled down by gravity, but the floor here, we do not want it to be moving. And the way that we can tell the rigid body, we do not want gravity to affect this object. And in fact, we don't want anything to be affecting this object. We want it to stay right where it is. And the way we can change that is click floor in the hierarchy, look at our rigid body 2D component down here, and you can change the body type from dynamic to kinematic. And that's it. And yeah, body type to kinematic. Now if we hit our play button, we can see that the floor doesn't move. We're getting somewhere. Oh, we're getting somewhere. And now the part you've all been waiting for. We can finally write some script. Yeah, coding. We can, yeah, basically, as I said earlier, every Unity object is made up of a collection of components, and in order to give our player controls, we can give him a script component. So if we go down to add a component here, and we're not going to be choosing from one of the default components that Unity provides here. We're going to be actually creating our own. And the way that we do that is simply type the name of the script that we want to create in here. Let's say it's going to be controlling our player, right? So let's call it player controller. If we type that out here, it recognizes that that script does not exist, and our only option is to create a new script. Oh, I put a capital L here. It's good to get out of the way fast. That can be annoying. We want to click new script, and it takes the name that we typed into the search bar. And all we need to do now is hit create and add. And now we have our script attached. Unity takes a little while to load it up, reloading script assemblies, and soon we will be able to edit it. Before we do that, though, how are we going? We got all our scripts attached? Yeah? All right. Before we edit it, we can actually, I'm sure you guys have all kinds of code editors installed. So to make sure it's using the one you want, we can go up to the Edit tab in Unity here, up there in the corner, and go all the way down to Preferences. That's Edit and then Preferences. And then you can see that there are a whole ton of options here, but we want to look at external tools. So again, that's Edit, Preferences, External Tools. And the very first one here is our external script editor. That's what it's going to open our scripts in when we want to edit them. So my editor of choice is Visual Studio. You can use whatever you want. Yeah, I'm Visual Studio. So make sure that's set to the editor you want to use, and you can go ahead and make sure you got your player selected. Go look at that script we just added. our player controller, and now we can click these 3 little dots here. Oops, that was a right click. Don't want to right. Oops, didn't want to open that menu. You want to click these 3 little dots here, and hit edit script, and yeah, reiterate, little dots, edit script, and now we wait for like a couple seconds, depending on how fast your editor opens. Do you trust the authors of the files in this folder? Yes, because they're me. And you will see here that we have a lovely script here laid out for us by Unity. We don't have to start from scratch. They give us a nice little foundation to work off of. So, has everybody got their script open? Yeah? Yeah? All right. Actually, no, before we start editing the script, why don't we pause for a second? Anybody got any questions, any holdups?
Do we need to have C# installed for
No. No, Unity parses it itself, so you don't need it installed. And yes, that reminds me, this mysterious language we see here before us is in fact C#. And you may have looked at this and thought, oh, that's Java. And that's because it is really, really similar to Java. If you haven't used it before, basically within the scope of this workshop, I don't know if there's anything that we're going to code that can be considered to deviate from Java, like basically at all. So essentially, how many of you guys have experience with Java? Yeah, a lot of people. That's understandable. Then you basically have experience with C#. Congratulations. But otherwise, just follow along what I'll be typing, and hopefully you'll be able to get some the code. Yes, good idea. Hopefully you'll be able to gain some understanding of C# as well. So, Control plus, right? Yeah. On the Mac, it's Control and Scroll wheel. There we go. How's that? More visible? Yeah. Well, all right. Why don't we take a look at what we've got here in this script of ours, in this player controller script of ours. We have a class, player controller. That's what we created, but it automatically inherits from this class called monobehavior, and that is Unity's built-in class that basically every component that attaches to an object in a scene needs to inherit from monobehavior. That's just their editor foundation script. So all of our scripts that we create in Unity are going to inherit from monobehavior. And monobehavior also comes with a whole bunch of handy virtual methods that we can overwrite. And here, by default, we have both start and we have update, and they also come with some handy explanation. Start is called before the first frame update, and what that means is anything that you write in here gets called as soon as the game starts. As soon as you hit that play button and the scene opens, the start code is going to get called. And then in update, update is called once per frame. So anything, if you're going to want to be making consistent checks, all of your controls and stuff, that's going to be, consistently going on throughout the game, that's going to be in your update function. Case in point, let us write some code. So right now, why don't we start with something small? We are going to make our player character jump when we hit the space bar. And to do that, recall that we added a rigid body component to our player, and that handles all of Unity's physics and stuff, right? And something else you can do with rigid bodies is you can apply force to them to move them in different directions. And a very common method of creating jumping mechanics in Unity is by applying force to a rigid body in the up direction to, launch it off the ground. So that's what we're going to be doing. And recall, if we look back at the editor, all of these scripts, the script that we created, the box collider, the rigid body, and the sprite render, they're all components all attached to the same object here, our player. And we can actually get a reference in our written code here in our script to each of these components using a special method provided by Unity. and then we can basically manipulate our components within our script, which is pretty cool. So we're going to go ahead and declare a variable here. So we need a reference to our rigid body component, and it's pretty straightforward. We're going to create a variable of type rigid body, both be rigid body 2D, and we can call it whatever we want. I usually like to go RB for shorthand, and we can just leave that uninitialized, just like that. And but now we need to initialize it, of course, because just like this, it's just going to be, if we tried to do anything to it, it would just give us a null reference exception. So we need to actually set it. And remember, start is called in the, as soon as you start your program, your game. So we're going to want to do any setting of initial variables, any grabbing of other components in the start method. Well, might as well check. Everybody following so far? Yeah. Got a private rigid body. Pretty cool. And now in our start menu, let's set this baby. We got RB equals, and get ready for this. If you intend to continue using Unity, you will be seeing this command so often you will be seeing it in your sleep. Get component. And what this method does is it lets you get the component of the type that you specify that is attached to the game object that this script that you're writing is attached to. So since our player controller is attached to our player, if we were to type get component, and now we need some triangle brackets, rigid body 2D, recall that's the type that we need, and then open close brackets to complete the function. What this will do is it will check our object, which remember in the editor it's a bundle of components. It's going to look around. It's going to say, do I have a component of type rigid body 2D? Oh, I do. It's right here. And it's going to grab that, and it's going to send that reference to our script right here. And now we have access to our rigid body. And so why don't we, before we do any input checking or anything, why don't we just make sure that this all works? That this rigid body we have here is indeed the one that we have in our scene. And why don't we do that by, in our start method, why don't we apply that force to make him jump? So he won't be jumping when we hit the space bar, but let's see if we can make him jump right when the game starts, just to see that we have everything in order. And the way we can do that is RB dot apply, add force. And essentially, yeah, each default type provided by Unity has a whole ton of methods available for them in the script editor as well. So there's, yes, it's all provided for you. It's all very cool. It's not, I'm using a friend's laptop, so it's not set up, but having like code suggestions on your editor is very, very helpful, because whenever you type RB dot or something like that, it will show you all of the methods that are available at your disposal. And that makes just the whole coding experience, let me tell you, probably twice as pleasant. So if you intend to continue with Unity, I really recommend trying to set up some kind of code suggestions. So rb.addForce. So this method actually does take a parameter, and it takes, in fact, a vector3, which is Unity's 3-dimensional vector type. And essentially, well, I'm sure most of you have taken linear algebra. A vector is, what's the formal definition again? It has a direction and a magnitude. So you want to give it a vector to define the direction you're applying the force in and the magnitude of the force that you're applying. And the way we can do that is, well, first of all, why don't we go up and declare another variable up here. Let's make it a float, and let's call it jump force. Private float, jump force. And we can set it default to something like, this may seem like a ludicrously high number, 500. But trust me, that's just how Unity's force scaling numbers work. So we got our jump force at 500. We have our magnitude, but how do we get our direction? So Unity has this built-in class like I mentioned, vector 3. And on top of being able to create a vector 3 and define its x, y, and z values, you can also, if you want just a cardinal direction, you can type vector 3 dot, say, up. And that will give us the direction pointing straight up. There's also vector 3 dot left, vector 3 dot right. It comes in handy quite often. And what we can do to apply the magnitude is simply multiply it by our jump force. And this should function. This should do something right now. If you guys are up to this point, first of all, are we up to this point? Are we all grasping it? Yeah? Yeah! Yeah! Now, let's all go back to our editor. Yes? Oh. Oh, yeah. Yeah, good question. You can also use the vector 2 because we're in 2D here, but essentially, if you put a vector 3 in as a parameter to any function that requires a vector 2, it'll just like crunch it down and take the first two elements. So yeah, we don't care about the z. Yeah, it's kind of handy that like vector 3s map down to vector 2s automatically in Unity. And yeah, for anyone confused, vector 2, it's just like it's a vector with an x and a y without the z, so in 2D space. But yeah, why don't we hit that play button and see what happens? Whoa! Oh my god, did you see that? Oh my god. We got it. Ladies and gentlemen, we have created a game. Well, actually, we've created functionality. I suppose we would have to have controls in order to have created a game, which we can actually add right now. And it's almost just as simple. Unity, all of this stuff is, it's like, I've been trying to learn how to make games with JavaScript lately, and oh my god, it's so hard getting away from Unity because everything is just so simple. In order to check for a spacebar press, we want to do that in update because we want to be checking every frame whether the button is being pressed. The way we can do that is by typing input. Input is another class provided by Unity. It has a whole bunch of handy methods, but the one we're going to be looking at right now is input dot get key down and a pair of brackets. And this is a case where having code suggestions would be really nice because it's not like JavaScript or something like that, where in order to check a key, you have to look up a map of what all the keys are called, and then find that string and then put it into the brackets. What you can do is actually Unity has another class, key code, or I guess it's not a class, it's probably an enum, key code dot, and essentially just type the name of the key you want. So if you wanted to check if the F key was pressed, it would just be key code dot F. If you wanted to check if the space bar is pressed like we do now, key code dot space. And this, well, we want to put this in an if statement because we want to check that this returns a Boolean. It returns true if key code dot space. The space key has been pressed on this frame, and false if it hasn't. So we want to check if input has gotten key down, key code dot space, and then get our curly brackets out there. Here is where the magic happens. Remember this rb.add force command we wrote earlier? This line we wrote earlier, we can copy that, get it out of that start method, oops, get it out of that start method, and put it into our if statement. And maybe fix the formatting, because Visual Studio here is not set up to automatically fix that. But yeah, now if you've gotten this far, have we gotten this far? All good? Yeah? Are we ready to see some game? It has all been leading up to this. Get back to your editor, wait for those scripts to compile, hit the play button, and well, nothing happens right off the bat, but hit that space bar and oh my god. And you can do it as much as you want. You don't even have to wait till you get back to the ground. You can just keep hitting it in the air because we didn't add that function. Although that's also very simple to add. And well, I don't think we'll have time to add it, but anyways, we officially have game. We have a character that you can control.
Can you go
Yeah.
back to your code?
My code, absolutely yes. Yeah, so that is essentially how the scripts work in Unity. The basic workflow is you grab your components that you're going to need to reference in your code, then you initialize them in your start method with the get component command, and then you can check for input with the input.getKeyDown. You can check with, or you can add a force to a rigid body with the rb.addForce command. And this isn't just for jumping. It could be for literally anything you could possibly want to add force for. It's versatile. It's cool. Now, so I think we've hit. Oh, question? Which one gets the force applied to it? Like between like the player or the floor, for example? Well, see the when you do get component, this it applies automatically to the object that this script is attached to. So since this is only on our player, yeah, it'll get our player's rigid body. Yeah. Yeah, no problem. Any other questions? Yeah? If he's floating up? Well, wait a second. He's floating up into space? That's bizarre. You see, the reason that might happen. Did you change the player's rigid body 2D type to kinematic? Because the player should be dynamic. That might be it. Was that it? No? Okay. Okay, alright. Next is take a look at his gravity scale parameter right here on the rigid body. How's that looking? Is that 1? It's 1? And your jump force was 500, not like 5 million or something? Holy crap. And your code looks like this too? Vector 3.up times your jump force? That's a mystery. He just doesn't come down? Are you pressing space a bunch of times? Or just pressing it once? You don't have key down. Oh, well that's that. Well, you gotta put in your key down, because otherwise the force is being added every single frame. So he's just getting pushed off into space. Yeah, gotta be careful about that. Well, yeah, make sure to have that within the if statement, because this if statement, everything in here happens when space is pressed. Otherwise, all bets are off, and it happens every frame, and then just everything goes crazy. So, why don't are we good to move on? I think we're good to move on. Oh, question? Then you probably forgot to add a box collider to the floor, because the floor has to have both a, call here, you click your floor here on the left, and you look at your inspector here on the right. You're going to want to have both a rigid body 2D set to kinematic and a box collider 2D on your floor. And yeah, and hopefully he should have something to stand on. Anybody else got any questions, comments? We can use comments at this point too. No? Well, oh wait, I see a hand back there. Yeah? Do you have a... Wait, I can't hear you. He's going up? He's not going up? That could be any number of things. You have, does your code look just like this? Then, does Mac have a rigid body attached to him? Is his body type, his rigid body's body type, kinematic or dynamic? You want it to be dynamic. It's dynamic? Wait, is it working now, or is it still not working? Now that's strange. I think you're gonna have to, yeah.
So what's the difference between like what other things would you like add like kinematic like
A kinematic rigid body?
yeah.
Well, say like, actually, I suppose if we get the chance to add obstacles, we're gonna want to like say you want something that like scrolls across the screen, like you're gonna want to jump over to dodge it. You want it to have a rigid body because you want it to be able to collide with the player, but you don't want it to be affected by the physics. So you know, like you don't want it to bounce off of it. You want, yeah. So kinematic. There's also static body type. Static means it never moves no matter what. So that would probably be better for a floor. Kinematic means you can only move it through a script. So like it won't interact with the physics system, but you can move it by script. So it never moves. Dynamic is yeah. It's bounce all over the place. Like honestly, we can do some experiments while we wait here. Mac is basically like a little football here. We can like if we go to our scene view, we can pick them up and drop them. We can like rotate them. Oh, yeah, sure. One wait, yeah. Hold on. Let me just look at the scripts. You know, I think this has been pretty productive so far, all things considered. We got through creating objects, adding in sprites, importing sprites, setting sprites up, and writing scripts. This is the basis of Unity. We're getting somewhere here, you know. But yeah, like if we wanted to add in, say, like another square. Also, any changes that you make in play mode, so while the game is running, they get deleted once you leave them. So you can add stuff into tests, you can change values to test stuff, and then when you leave play mode, they all get reset back to their values, their default ones before. So that comes in handy when you're playtesting stuff. So we have a square here. Let's give it a. How is it looking right now? Is everybody caught up? Are we all good? Or are some people still getting help? Or are we good to continue? We're good? All right. Why don't we having Mac be able to jump. So we all got Mac's controls working. He jumps when you hit the space bar. He launches into the air. All good? Can we get some thumbs from the back? Yeah. All right. Now, why don't we make this a bit more of a real game? Let's add some obstacles. So, in regards to obstacles, Mac, as you can see, he's a bit of a cowboy-esque type character. He's got his hat and his cape there and his lasso. His enemy that we're going to create today is going to be a tumbleweed. And we can make it more intimidating than the average tumbleweed. We can make it bigger. Why don't we do that right now? Why don't we create it? We can right-click in our hierarchy, recall, go down to 2D object, hit sprites, and you know what? Why don't we make a circle this time? It's pretty revolutionary in this world of squares. Have a circle. Of course, we're going to change it. We're going to change the sprites pretty much immediately. If we go back to our sprites folder or wherever you have the sprites, there's this one. This set of tumbleweed sprites. It's also a sprite sheet. If you haven't sliced it, we can just go over that again now real quick. You can click the little bars there to remember these import settings. If you have pixel multiple, you can set to that. But if you just send it up with the pixel single one, you can set it to that. And now we just need to change the sprite mode to multiple. Hit apply on the bottom here. Scroll back up and hit sprite editor. We got the slice menu. Let's hit slice. Change the type to grid by cell count. Hit the column and row. Set it to 4 columns. Hit slice, and that will give us our 4 sprites. Now it does seem like a pretty obscure workflow, but you really do get used to it, because you may find yourself slicing a lot of sprites. And yeah, go to our circle, which is in fact not a circle, it's a tumbleweed. So let's change its name to tumbleweed, why don't we? Right there in the corner. Tumblewood. That's not the same thing at all. And now we can, if you recall from earlier, we can grab one of our tumbleweed sprites and drag it in and drop it into our sprite renderer sprite. And now we have ourselves a little tumbleweed. And I still have the movement controls open. If you don't, you can left click it, hit W, and drag it on down. And here's our tumbleweed. Isn't that something? Thank you. Thank you, everybody. It is a tumbleweed. Yeah, let's, alright, we're pausing for a second. Any questions? We've all got our tumbleweed set up? Yeah? Anybody got any questions or no? The slicing or the... Yes, applying the sprite to the tumbleweed. Well, if you've got your sprites all sliced, how did I just change the name to W when I wasn't looking? Well, you see that our tumbleweed has sprite renderer. You're going to want to just grab the sprite from down here in your project folder and drag it up and drop it into the sprite parameter. And yeah, that should working. All right, let's get this show on the road. So we want to do what we did before. We want to give our tumbleweed a box slider and a rigid body. Let's get that rigid body out of the way first. Rigid body 2D, if you recall. Add that. Then add component again. And you know, we could add a box slider, or we could add, wait for it, a circle collider. And that will automatically conform to the shape of our sprite here, which is really cool. As you can see, the green outline indicates the collider space. Yeah, for Mac here it was a green box, but our tumbleweed is a green circle. And our tumbleweed, we want it to be continuously moving to the left. We want it to say, come from the right of the screen and just come barreling in, and it will test the player's reaction time. They will have to jump over it, lest they face the consequences of being struck by a tumbleweed. And actually, why don't we just go up to the scale here in the inspector and change it to like 1.5 or something. And now that's a pretty big tumbleweed. It's like, it's person size. That'd be pretty, you saw that barreling towards you, you'd want to jump over it too. So what we can do now is, in our game, we want these to continually spawn. So if we think back to the mission statement of this game, a infinite 2D runner like a la Jetpack Joyride, you're going to want to be running, and these obstacles are going to be continuously coming at you from, say, the right of the screen. And we're going to need some way to spawn them in, to duplicate them, never-endingly. And the way we do that will be, you guessed it, through another script. So we're going to go into the hierarchy here, right-click again. We're going to create an empty object this time, and it will be, let's call it the game manager. And we're just going to have this invisible object just floating out there in cyberspace, and we're going to attach to it all the scripts that are going to overarchingly manage our gameplay. So we're going to go ahead and highlight it in the hierarchy, click Add Component, and let's call the script Game Manager. And click New Script, and it's got our name written out, and hit Create and Add. And now we wait for it to compile to generate our little empty script right there. And now back to the code editor we go. We're going to click the 3 dots and hit Edit Script. And you know, before we get started on the script, it is 8:28. We are dangerously close to approaching pizza time. How's it going there in the back? Are we taking a break? Yeah. Guys, hack the hill, guys. It's 8:28. Do we want to have the break before we move on to the next script? Up to me. Well, I say we've earned some pizza. So Yeah. Yeah, we should take a break because we're about to start something new here. So, all right. So, how long do you think it'll be good? Should I have to pull it in an hour, 20 minutes? Well,
Sorry, can everyone stay seated for 1 second?
oh yeah. Well, we have to be able to finish what that's not good.
Okay, you want to do like a 20-minute break?
How many points will it be? 15 will be pushing it.
We can do 15. Just not up to meeting. Like, whatever you think is better.
It might be, yeah, it might be good to break and then you can make sure everyone's on the same page and then when you leave, it will be like
Okay, we're gonna have 2 lines at the back. Manal, can you wave? 1 line where Manal is. Sasha, can you wave? 1 line where Sasha is. There's 2 lines. We're gonna have a break for 20 minutes. Please get your food and go back to your seats. We're gonna be starting back in 20 minutes.
Our trek through beginner Unity. We wanted to show you guys. We did finish the game. Just so you guys can get an idea of the kind of power you will have if you master Unity. What? Yeah. If everybody would like to take a seat, perhaps. Before we unveil this epic creation, we will be getting back to the workshop proper just after this because we really want to show you guys. It's really cool. Well, anyway, we have audio hooked up here. Man, we can post some music for it. So. Should probably turn it down quite a bit. Yeah. Uno secondo. Yeah. It's good as long as it's. Yeah. Freya told me to wait a second. So. Screen, I'm gonna play it. If you're not looking, you're gonna miss it. Yeah, this is the full game. It's still pretty well, we finished it a couple hours ago, so it's a little bit lacking in mainly the area of UI, but it's playable. It's a very functional game. You'll see the start screen, the title screen here, created by our vice president Freya. Again, very cool. The audio actually, it's coming out of my laptop. All right, how do I do that? This is important. Okay. Yeah.
Yeah, it's at the bottom. System preferences.
Got it.
And then change it to
Press on. This is the only one that was not there before, so I don't need to save it or anything. All right. Volume. Okay. All right. Hopefully this won't blast anybody's. But all right. Behold the soundtrack composed by our very own VP Bilingual Malin. Let us Check it out. Unity can be slow sometimes. Isn't that awesome? Look at Matt, guns a-blazing, out here in the Wild West. The size is weird. Oh, oh you're good catch. There it is. Yeah. You should get up here. All right. Let's start this game. So, let's start this game. Let's start this game. Oh, well, this is something. I literally tested it like 10 minutes ago. Well, debug. All right, here's what we can do. We can do some quick on-the-fly debugging and copy the music player from the intro scene and transition to the main scene, paste it into the main scene, and then play the main scene. And this should, if my years of experience have not led me astray, this should. That's not snow. Oh God! Look at him go. We died already. Well, that's okay because we can restart, and that button works. That's good. But yeah, pretty cool. Again, the background basically we separated into parts and made them all scroll at different speeds. This is called parallax scrolling, and it's really cool because it makes everything look like it's at different depths. Wait, is the music not working? I think the music may not be working. Death music? Alright, there is a special track when we run into a tumbleweed and die. Let's see if it'll play. Isn't that cool? Try and get the high score. Alright. I'll talk a bit about it while we get the high score, before we get back to the workshop, which we will after I die here. But yeah, this represents the culmination of the week we had to prepare the workshop. It was probably about between like an hour and 2 hours of coding by me, and like probably like a full day's worth of art by Shreya. And I don't know how long it took for the music, but a very substantial amount of time. So a lot of care was put into this piece of art. We really wanted you guys to see it, if you weren't going to be able to make it. So we've died. 421. That's one off from 420. Sorry. Yeah. Sorry, what was that? Oh yeah. Yeah, that's it's a different component. Because we have the box slider on here, and oh wow, it's really small. But I don't know if you can see it, but there's a component called a polygon collider that you can create new points in it and like morph it so it exactly fits here. Yeah. So we'll now be getting back to the workshop proper. Thank you for indulging us, everybody. I shall now. Thank you. You're too kind. I shall now be switching the HDMI cable. Is this HDMI or is this display? It's a display port on the Mac, and I was checking the sounds. But, anyways. Wow. There it is. Our beautiful script. Now, it is already 9:18. I'm thinking we're not going to go much longer. Thank those of you who have stayed. Thank you so much for staying. We really appreciate it. Yeah, this we had a lot more planned for this workshop, but like I mentioned, it's the first one we've ever given. So hopefully the next ones will be better. But I hope you guys feel that you're taking something valuable away from this workshop. But let's get the show on the road. I want to hopefully get us out of here before like 9:45 or so, because I don't know how the weather's looking. I haven't looked outside in a while, but I hear it's not so good. And I'm sure we'd like to get home. But, all right, where were we? The game manager. So basically what this script is going to do, right? It is going to handle the cloning of that tumbleweed object we created earlier. It's going to clone it, and it's going to move it in the direction of our player. And the player will have to jump over it. So the way I'm thinking of doing that is we're going to have a list here in our game manager, and that's going to contain all of the tumbleweeds that are, that are active in the game right now. And every frame in the update method, it's going to move them a little bit to the left. And what that will end up looking like in the end is a whole bunch of tumbleweeds moving in procession, which is what we want. But then we also want something set up to spawn them on some sort of timer. So the first thing we're going to do here is we're going to take care of the issue of spawning the tumbleweeds. So in Unity, when we want to clone an object, the first thing we need to do is create a prefab. And what prefabs are is basically, let's go back to the editor and I can show you. The first thing we should do is, well, let's go to our assets folder. Remember this tumbleweed we created? Let's go ahead and, is that right? Let's go ahead and make sure that it is moved off of the screen to where we want it to spawn when we create it. So right now it's just off the camera. That's where we want it to be. Now don't ruin the illusion. Make it come in from off screen. And now in order to turn this unassuming game object into a full-on prefab, we can grab it in the hierarchy here on the left and drag it into our folder and just flip and drop it in there. And look, it's a tumbleweed. So basically what a prefab is it's like a template for an object that you've created. And when you want to like duplicate an object multiple times, you want to spawn it in your game, this is the object that we need to reference, because Unity checks it and then creates an object with all its characteristics. So that's our tumbleweed. And now we can actually delete our tumbleweed from the scene, and it will stay here in our prefab. And then if we ever want a new one, we can just grab the prefab that we created and drag it into the scene and drop it in, and oh, there it is again. Isn't that crazy? We can even make a bunch of them. Well, we'd have to move them around because they're all stacking on top of each other, but you get the idea. So yeah, just to reiterate, that tumbleweed object you created, you grab it in the hierarchy, drag it into your folder, and drop it in. Have we all got our prefabs? Yeah. All right, now, we need in Game Manager, in order to spawn these, we need a reference to the prefab in our script. And the way that we get that is we're going to make actually for the first time a public variable. And that variable is going to be of type game object. And we're going to call that our tumbleweed prefab. And so now recall we used a get component to get our rigid body earlier. But this isn't a component that we want to get, it's a prefab. How are we going to get it? Well, the difference that using public instead of private in terms of a variable declaration within a MonoBehavior class, the difference that it makes is that public variables that you create, make sure to save your script before you go back to the editor. Public variables that you create show up in the inspector. So that tumbleweed prefab variable we created, that field is right here on our game manager script. And as you can see, it is empty right now, but it requires a game object. So that tumbleweed prefab that we made here in our folder, we're going to grab that and drag it into the box and drop it in. And it's as simple as that to get a reference to the tumbleweed. We all here, we've all got the tumbleweed in our tumbleweed prefab field. The code? Most certainly. Yeah, you're just going to want public game object tumbleweed prefab. Yeah, we can take this pause to note. Game object with a capital G is a type in Unity, but if you use game object with a lowercase g, this refers, it's in MonoBehavior, it refers to the game object to which the script is attached. So it gets a little confusing because both of them are used quite often, but yeah, just that distinction. Whenever you're using it as a type, you want the capital G, and yeah. We good? Are we all good with the code? Yeah. And then for those of you who may not have been able to get the tumbleweed in there, just go to your game manager on the left, grab the tumbleweed prefab, and drag and drop it into the open box right here. All right. Are we good to continue? I will take that as a yes. Yeah. Now we can go back to our code. Now, we want to spawn these tumbleweeds, and we want to spawn them on a timer. So there are plenty of ways to there are plenty of ways to do anything in Unity, but there are specifically plenty of ways to make a timer. And my preferred method involves something called a coroutine, and you know, just from the name, you may be able to tell it harkens back to multi-threading if you've covered that in your classes yet, or if you've heard about it. But it's not so literal as multi-threading. Actually, I guess it's more literal. Basically, we want to create a new method. Let's call it, actually, wait, let's make it private. And the type we want it to return is actually IE, it's capital IE numerator. IE numerator. And we want to call this method something like, let's say, spawn obstacle. And then it takes no parameters. And yeah, yes. Almost certainly. You go to your editor, you grab your tumbleweed wherever it is in the hierarchy. Mine's deleted from the hierarchy, but you grab it, and then you drag it and simply drop it into your assets folder. Yep. And yeah, all good? All good. But yes, this IE numerator method, isn't that mysterious? Basically, when we have a method like this, that returns IE numerator, it affords us some very nice liberties, such as we can pause the method whenever we want with some special syntax. So let's think back. We want our tumbleweeds on a timer, but we want them to be, you know, pretty consistently spawning, but probably not on an exact, like, every few seconds timer, right? We could spice it up a bit and make it, you know, a little bit random. So why don't we declare some public floats? Let's call them min spawn delay and set that to maybe like 2, and then comma max spawn delay and set that to maybe 3. And now we can, well, we're going to use these to basically spawn a tumbleweed, then wait a random amount between 2 and 3 seconds, spawn another tumbleweed, repeat that indefinitely. And so how we're going to do that is, well, yeah, oh yeah, yeah.
So you want to make like easy and hard mode, right?
Yeah.
Would you just not declare those like up there, and instead you'd have like say an if statement saying changing the delay
Yeah.
inside your update?
Well, if it were something like if there were like a button or something the player could click to change the difficulties, buttons in Unity have like, you can tell them to call a function when you click them. So you could call like a on difficulty change method and have it be like in that method you could change the spawn delays. And yeah, so here we're going to want it to repeat indefinitely. We're going to call, we're going to make a usual programming no-no, a infinite while loop. Yeah, except we are going to put in some magic code here to pause the method for a certain amount of time every iteration of the loop, so that it is not, in fact, it does not freeze your program. It is infinite, but it does not cause any harm to the actual program. And how we're going to do that is we're going to type yield, not YURL, yield, return, new, wait 4 seconds, capital W, capital F, capital S, and then in the brackets we're going to put the amount we want the method to wait before resuming function. And so we said we wanted a random number between min spawn delay and max spawn delay. Well, that's also really simple thanks to C#'s built-in random class. Just going to say random.range, capital R. All default methods start with like capitals in C#, so make sure you got a capital R at the start of the range. And In your brackets here, the range function, we'll put our min spawn delay, and our max spawn delay. And this is not going to do anything just yet. It will wait for a random time between min and max spawn delay, and then it will wait again. So we need to add the cloning of the tumbleweed in here, don't we? And that is similarly simple. So what we're going to want to do is use another built-in Unity function, instantiate. Some people say instantiate. I don't know, that just doesn't sit right with me, so I say instantiate. But and in the brackets, we want to put our tumbleweed prefab. And it's as simple as that. It takes the tumbleweed prefab and it clones it. This method actually returns a game object, which is the clone that it has just created. And the way that we can get a reference to that is by game object t, or tumbleweed, let's say, equals instantiate tumbleweed prefab. So now our tumbleweeds are created. So if we were to go back to the editor and hit that play button and see what happens. Oh, actually, wait. Nothing's going to happen because we never started the coroutine. And the way we can do that, that's important. We're going to go into start and then type start coroutine. And then in the brackets, spawn obstacles. We just call it like a regular function here. If you call spawn obstacles without start coroutine, nothing happens. Whenever you have a enumerator method, you got to call it within start coroutine. And yeah, so once we have all of this down, are we good to give it a test? Has everybody got our code down? Yeah. Yeah. All right, let's see what happens. Oh, wait a second. Nothing's happening. Why don't we check the scene view to... Okay, wait. Something's supposed to be happening, but it's not supposed to be showing on the screen. Wait, okay, so you started the coroutine, it waits and it instantiates the... Okay, something's wrong. What? Where? I don't know. Well, all right, let's diagnose this. So something's clearly gone wrong. In our game manager, in our start method, we've called spawn obstacles. Spawn obstacles, we've got while true, yield return new, wait for seconds, random.range, min spawn delay, max spawn delay. Game object t equals instantiate tumbleweed prefab. Okay, this is what's called live debugging. No, but that's the thing, is it should be visible in the hierarchy. You guys it is. Then I made a mistake. What's oh, did I not save my script? I didn't save my script. Classic mistake. I'm 5 to 6 years into Unity and still making that mistake. Let that be a lesson. To you and to me. And now, yes indeed, it is spawning the tumbleweeds. You can see in the hierarchy, we have a tumbleweed clone. Ominously titled clone in brackets. And they're stacking up, but they're not moving. Oh, they're falling actually. Yeah, so what we're going to want to do is first, let's edit our tumbleweed. We don't want them to fall. We want our tumbleweeds to move smoothly from right to left, which is to say, we are going to click our tumbleweed prefab, and then we can still edit its components while it's a prefab. We're going to scroll down to rigid body, to its rigid body component, change it to kinematic. That's important. Now it will no longer fall. That's not the first thing we have to change. To recap, we went to our tumbleweed prefab and changed the rigid body type to kinematic from dynamic. Let's go back to our script. Now we want to actually move them. So let's see. What did I say before? We wanted a list of game objects, and we're going to iterate through them every frame and move them each a little bit per frame. And the way we can do that is by declaring ourselves a little list of game objects. That is the simple list syntax in C#.
Let's call that scrolling object. Just like that. And of course, in our start method, we're going to want to initialize it as an empty list, lest we get a null reference exception. And of course, with our open and close circle brackets. And once we have all that, we are going to move down to our update method. So far we've encountered not very much like base syntactically that differs from Java when it comes to C#, right? Like a few things here and there that are like tiny differences. The list, like we use list instead of array list. But here's the one thing that we cover here that's really different from Java. The for each loop syntax is like this. For each game object, G in scrolling objects. And that's our for each loop. No colons or anything necessary. Yeah, we have our G that refers to, that's going to refer us to each of our objects that are inside the list, which is to say each of our tumbleweeds. And again, there are plenty of ways to move an object through a script in Unity. We are going to take the simplest approach, which is to use the object's transform component. So remember that if we go back to the editor really quick, every single object has a transform. So our game manager has a transform, our floor, player, camera, all have transforms. So instead of having to do object.getComponent transform, you can just do g.transform. It's by default, every single object you can access its transform this way, and then we can access the position value of the transform with .position. Fancy that. And we can actually just simply give it a little plus equals and add to it, remember vector3.up or vector2.up also would work. Let's just, for the sake of consistency, let's use vector3.left. Oops, .left. And we're going to want some kind of speed value, a parameter to scale this by. So let's go back up and write ourselves a quick little public float scroll speed and say, we'll leave that at like 6 or something. And let's scroll back down. We're going to want to multiply this by scroll speed. But now this is very important. Whenever you do some kind of, apply some kind of movement or increase in a value in the update function, there's something you have to take into account. So if you recall, update is called once per frame, but different computers have different frame rates. It's very heavily dependent on the specs of a computer. So a low spec computer might have like way less frames per second than a high spec modern one. So when you're doing something like this, if we were to leave it like this, simply translating it by vector3.left times scroll speed every frame, the speed of the game would not be consistent on different computer systems. Thankfully, Unity also has a really easy way to deal with that. We simply multiply this value by time, the time class, .delta time. And what time.delta time is it's the time that has passed since the last frame. So it basically equalizes the values over time, regardless of frame rate. So yeah, I don't know if I can explain it super well, but the effect that this also has is that our scroll speed, whatever value we assign as our scroll speed, say 6, because of the way time.delta time works, basically over a second, no matter how many frames pass, time.delta time is going to add up to 1. So what ends up happening is this value that we declare ends up being the speed per second of our tumbleweed. So our tumbleweed is going to move 6 units per second. Simple as that. So how are we doing? Have we been able to follow? Yeah? Good question? Certainly. Anybody else got a question or any issues? No? That is excellent. That is great to hear. All right. Want me to scroll down and show anything else, or are we good? Okay, no problem. Now we can. Oh wait, let's think for a second. We've got this working. It spawns them. It moves them. Let's check the game. Let's check what happens. We shall hit our play button, and I think, well, let's have a look. They're not moving. Okay, ladies and gentlemen, this is because I forgot to add them to the list. Yes. Wait, I can't quite hear you. No, just the obstacle into the script. Like like the tumbleweed prefab field. Make sure that you've got your and then you're good. But yeah, we need to go back to our script, back to our spawn obstacles field, and what the heck? We never added T to our list of game objects. So we're gonna go scrolling objects dot add with a capital A, of course, T. Then we can save that. It is literally that simple. We can go back to Unity, give it another try. Once it loads, that is something that's a little annoying about Unity is whenever you change a script and come back to the editor, it takes a second. Oh my god! It's tumbleweeds! Holy crap, what happens if one hits us? What'll happen? Oh no! Oh my god. That was brutal. Oh, he's gone. He got pushed right off. Where is he right now? If you click an object in a hierarchy and press F, you can zoom in on it. So let's see. Oh, he's fallen so fast he's already gone. He's reached terminal velocity. He's at almost minus 2,000 on the y-axis. Let's finish that up. So it is nearing 9:45. I didn't want to. Well, this is as much of a game over as it gets, you know, like getting launched off of a platform to fall to your infinite demise. I think that's pretty climactic. Oh yeah, in the last couple minutes we have, why don't we put the background in? Because the background and the floor, and that's a very simple process also. So, if we come back to our hierarchy here, we are going to, as we have done many times before, as we are intimately familiar with, we're going to go to 2D object, sprites, and who else but the square. Except this square, we are going to, we're going to go to our sprites, and one of these should be, yes, background underscore combined .png. Let's import it. Let's make sure to import it properly. So let's go to, well, actually, you know what? Let's take this opportunity to show you guys what it looks like when you don't apply the import settings. Oh wait, that actually looks fine. Wait, that's where this is supposed to happen. If we blow up the scale, this is going to be. Okay, if you look really closely, you can see some smudging. Yes. See, this will not happen once we apply our import settings. Call our pixel single. Remember to highlight it in the folder. Go up to the little two bars, and that pixel single set of preset values we created. Hit apply, and look how sharp these pixels are now. See? Yeah. Thank you very much. And yeah, let's scale this background down so it fits the screen. Our square, which is now actually our background. Let's say 1.5. 1.5 scale is probably. Yeah, that's. Or wait, it's hanging. It's not quite hitting the bottom. Let's just. How about 1.55? Perfect. What? Yeah. There is also, of course, the floor, which is floor.png down here. Apply our import settings and apply those. Grab our floor here and drag it drag it right on there, on a square. Ooh, it's kind of stretched out, and that's because we, oh, wait a second. What we should actually do here, because if I were to change the scale here to 1, the floor would be the proper size, the graphic would be the proper size, but our hitbox, remember, our hitbox for the floor that we stretched all the way out, it'll go back to being a single block. So what we should really do here is Control Z to undo all that, leave our floor as it is, but instead disable the sprite renderer. This little checkbox on our floor, check that, it's invisible now, no more square. And we can actually right click in our hierarchy, 2D object, sprites, square again, and now we can put the floor in. So we have, what else? A floor, a fake aesthetic floor here, and a real invisible floor. That's how you do it. You know, it's all illusions here in game dev. There's nothing to be, and that sounds kind of sinister, I realize, but it's not. I swear. Our floor here. Let's just bring it right up so it covers the bottom of our screen. Perfect. Beautiful. Now, if we were to play the game, well, it wouldn't be quite as glorious. Oh, there's a little bit of the vapid void background visible. So let's just go ahead and lift the background up a little tiny bit. There we go. And yeah, so you know what we're also realizing here is that Mac has disappeared. And well, the reason for that is pretty simple. It's that default tiling of sprites is weird. They just they go all over the place. Like if we put a bunch of sprites into the scene, Unity really does not know which one it's supposed to put in front of the other ones. But thankfully, we can tell Unity which ones we want to go in front by grabbing our player here in the hierarchy, going over to the sprite renderer, and down at the bottom of the sprite renderer, you'll see order in layer. This is the sorting order. If we put that any higher than 0, well, there he is. He pops right back up in front of the background because the background sorting orders are 0. So basically, it's the highest sorting order sprite gets rendered first. In fact, we should keep our floor here at 0 because the floor needs to be in front of the background. And we can make our background, we can actually take this into the negatives. So we can make that -1 just to make sure everything works. In fact, actually no, yeah, that should work. Now if we play it, this will probably be our final product. Would you look at that? He's got a background. Oh, the tumbleweeds are in the line. This is okay. This is indeed we lowered the floor earlier, but we did not lower the tumbleweeds. The tumbleweeds are still where we left them, so we're gonna have to tell the tumbleweeds to lower it down a bit. And that's also very simple to do. Where did we save our tumbleweed prefab? Mine was in assets. We can grab it, and even in play mode, we can edit it so that the Y value here, this is where it's going to spawn. We can grab that and lower it, and watch what happens. Oh, it's a little lower, but it's not quite. Oh, see you, Mac. It's not quite as low as we want it to be. So a little lower. Okay, maybe a little higher than that. A little lower than this. A little bit lower. There, perfect. And there's also one more thing we can do is we can go to the sprite render and also increase the tumbleweeds order in layer so that it renders above the floor. And just like that, we have ourselves somewhat of a game. Yeah, we are approaching, it is 9:48, we're approaching 9:50. I think we should probably call the workshop here. Thanks all of you guys so much for coming and for bearing with me because yeah, like I mentioned, this is my first ever workshop that I've hosted. I hope I was able to pass on some of my knowledge and perhaps ignite some inspiration in you guys. You know what Unity can do and what you can do with Unity. There's plenty more than this. We had a lot more planned, but yeah, you know how it is. Yeah. Thank you guys all so much for coming and for staying after the pizza break. Yeah. Thank you guys. Well, yes, of course. Should what? Play the game? The final game? All right, sure.